You might be wondering, how do scientists know how common each isotope is? Now, they use a machinery called mass spectrometry to work out the abundance of each isotope. Now, for your A-levels, you need to know. So the first stage is called ionization. There are two different types of ionization that you need to know about. Okay, so you need to remember their processes and characteristics as it will affect the MZ value. Now, the MZ value is just the mass of the isotope divided by the charge of the isotope. Okay? Now, the reason for this stage is because in later stages, the isotopes will need to be positive so that they can get accelerated and detected. The first type of ionization you guys need to worry about is electron impact ionization. Okay, here, a vapor sample is injected at low pressure. An electron gun fires high energy electrons at the sample. This knocks out an outer electron, forming positive ions with different charges. So basically, you have your particle here, and then an electron gun shoots high energy electrons at it, knocking off an electron from the particle to form a positive ion and just a random electron floating about. You don't need to worry about that random electron. Okay, it's this that we wanted. Now, this type of ionization is better for smaller molecules because it can cause fragmentation with bigger molecules. The second type of ionization you guys need to worry about is electrospray ionization. Here, a sample is dissolved in a volatile polar solvent, injected through a fine needle, giving it a fine mist or aerosol. The tip of needle has high voltage. At the tip of the needle, the sample molecule gains a proton from the solvent, forming Mh+. Okay, so here's our particle, and it just gains a proton here, okay? And this is how it becomes positive. So in both instances, you end up with positive ions, okay? Now here, because there's less breaking, it's better for the bigger molecules. Now, the different types of ionization have a different effects on the MZ value. So the MZ value, like I said before, is mass divided by charge. Now, when you use electron impact ionization, the mass of the isotope stays the same, and so you also have a charge of +1. So when you do the mass divided by the charge, you have basically this mass divided by +1, which is just basically the mass. So for electron impact ionization, the MZ value is basically just the charge. Okay. However, when you use electrospray ionization, you gain a proton, so the mass goes up by 1, and you have a charge of +1. Okay, so when you work out the MZ value, you do mass of the isotope +1 divided by the charge, which is +1. So then your MZ value is basically just mass of the isotope +1. Okay, and I've written that down here. Now, in rare cases of electron impact ionization, you can knock off 2 electrons, forming a +2 charge. So the MZ value will be the original mass divided by 2, because you have mass divided by +2. Okay, in stage 2, the positively charged ions are accelerated by an electric field from the negatively charged plate so that they all have the same kinetic energy. This means that the lighter ions will end up moving faster than the heavier ions. This is really important to know for the math questions in the later slides. We ionized them before so that the positive isotopes will be attracted to and accelerated by the negatively charged plates, okay? So here is our negatively charged plate, and here so this represents our negatively charged plate, and here are our positive ions. Okay. Now, because this plate is negative, the ions are accelerated And now all of them have the same kinetic energy. That's all that means. And if you think about it, just like logically, if you push something with the same force, two different balls, if you push them with the same force, the lighter one will move faster. Okay, same thing here. The lighter ones will move faster. Okay, stage 3. The ions enter a region with no electric field, so they just drift through it. Lighter ions will drift through faster than heavier ions. Stage 4, detection. The ions with a lower MZ value move faster and reach the detector faster. The detector detects charged particles and a mass spectrum is produced. When the ions reach the detector, they generate a small current which is fed to a computer for analysis. The current is produced by electrons transferring from the detector to the positive ions. The size of the current is proportional to the abundance of the species. Okay, so essentially, when your positive ion hits the detector, an electron transfers to the positive ion, and then a current is generated to a computer, and then the abundance is recorded. So the way the abundance is measured is, let's say with chlorine, for example, the chlorine 35 will produce a current 3 times bigger than chlorine 37. Okay. Now, from this, we can tell that chlorine is 3/4 of chlorine 35 is 3/4 of the chlorine, also known as 75%. And that's how scientists work this out, the percentages. Okay, so they look at the size of the current produced. So since chlorine 35 produces a current 3 times bigger than chlorine 37, we can work out the abundances. Mass spectrum. You get the MZ values on the x-axis and the percentage abundance on the y-axis. To work out the relative atomic mass, you need to do the same steps as before, but this time you need to read the values of the mass spectrum for the percentage abundances and the MZ values. So here, this is basically what we had before. I'm just going to cover this up and do it like this. So we have our percentages and our masses times together, and then all the separate ones are added, divided by 100 to work out the relative atomic mass, just like we did in the previous video. Now, diatomic atoms normally form bonds with each other, so if you have something like chlorine 35, you'd expect to look at around 70, 72, 74, because of the different combinations you can have. Okay, now it's time for an exam question. To state what is meant by the term isotopes. So isotopes have the same number of protons, different number of neutrons. Explain how in a mass spectrometer ions are detected and how their abundance is measured. So how ions are detected. The positive ion hits the detector and this generates a current. How abundance is measured. So the size of the current is proportional to the size of the abundance. Explain how the ions are accelerated and separated by mass in the instrument. So, like we said before, they are accelerated by a negatively charged plate, which accelerates them all to the same kinetic energy, and the lighter ones will move faster. Explain how an electric current is produced when an ion arrives at the detector. So an electron transfers from the detector to the positive ion.